Let's take some derivatives of inverse trig functions. The first one is f of t is equal to arc secant of negative 5t cubed. So what I remember is that the derivative of the arc secant of some arbitrary expression, arbitrary argument here is, let's see, f prime is 1 over the absolute value of negative 5t cubed times the square root of negative 5t cubed squared minus 1. Now I honestly need to check my table to see if that's right. Arc secant is not really one that I keep in my head that often. I did get it right. Now, it's not only this, but remember by the chain rule, we have to multiply by the derivative of this argument. So we take the derivative of negative 5t cubed. Okay? So the absolute value here resolves. This derivative is going to be negative 15t squared. So we're going to get negative 15t squared on top. We're going to get 5t cubed on bottom. And then we're going to get 25t to the 6th minus 1 on bottom, which then will resolve to the 5's will cancel and the t squareds will cancel. So we have negative 3 over t square root 25t to the 6th minus 1. And that's how you do that. You just follow the process. It's no different than really any other type of derivative. The next one is x squared times arc cosine of 2x. So that one's a little trickier because we now have an algebraic, we have sort of a polynomial expression multiplied by a trigonometric expression. So we have to use a product rule here. So the derivative of this is going to be the derivative of the first term, which is 5x to the 4th, times the arc cosine of 2x, plus, hold this one constant, and we have to take the derivative of arc cosine of 2x. Now the derivative of arc cosine is negative 1 over the square root of 1 minus the thing squared times the derivative of the thing. Which then gives us 5x to the 4th, arc cosine of 2x. So the derivative over here of 2x is just 2. So we get minus x to the 5th, 2 over the square root 1 minus 4x squared. And I'm sure that if you wanted to, you could combine these. You see that these have an x to the 4th in common. But realistically, this is perfectly fine. I don't really see any need to overly simplify this. So that what you notice though is that your final expression still has an arc function in it. There's no way to get rid of that because the product rule doesn't let us touch this arc function. So it is what it is. Now moving along, we have this expression. So this is sort of a continuation of, you're going to have a product rule, but in this case, your arc function is actually separate from your polynomial function, so you kind of luck out here. So in this particular case, we have to do a product rule here. So that is the derivative of x, which is just 1, the square root of 16 minus x squared, and then we leave x alone and we take the derivative of the square root of 16 minus x squared. So hopefully you are familiar and comfortable enough with derivatives by now to recognize that, or at least you can verify that derivative will be negative x over the square root of 16 minus x squared. Again, hopefully you can recognize that. If you can't, that's fine. Do some practice. But definitely just know that will get you there when this derivative is taken. Now, the 16 arc sine of x over 4. So to do that, we have to say plus 16. Now, the derivative of arc sine is 1 over the square root of 1 minus the thing squared, 1 over x minus 4 squared, times the derivative of the thing. Okay, so let's do some simplification here. We get 1/2 square root of 16 minus x squared plus negative x squared over the square root of 16 minus x squared plus 16 times 1 over the square root of 1 minus x squared over 16 times 1/4. Okay. So we still got a few things we can do. If we get a common denominator of 16 minus x squared here, we get 16 minus x squared minus x squared. We get that because when we get the common denominator of that square root, you have a cancellation there, so you get this expression on top. Now over here, that's just 4. One minus x squared over 16. And we could mostly be done here, but let's keep going. What you're going to find is there's going to be an interesting result. You're going to get that, so here, it looks kind of close to here. So what if I factor out like a 1/16 here? What if I say 1/2 16 minus 2x squared 16 minus x squared plus 4 1 over, if I pull out the 1/16, I get 16 minus x squared. Okay, that's interesting. But then I can take the square root of 1/16 and I get 1/2 16 minus 2x squared over the square root of 16 minus x squared plus 4 times 1 over 1/4 square root of 16 minus x squared. Okay, so then what I notice is that 4 divided by, so you don't get cancellation. That 4 and 1/4 don't cancel because that's in the denominator. So it's really like 4 times 4 over 1. So I'm going to rewrite that as 16 here. But instead of writing it there, I'm actually going to write it up here. So you have 16 over the square root of 16 minus x squared. The reason why I do that is then now I can combine these and I get 1/2 times 32 minus 2x squared over the square root of 16 minus x squared. At which point, I can then distribute the 1/2. So if I factor out a 2 from there and cancel, I get 16 minus x squared over the square root of 16 minus x squared. Which then, I can say, well, those are the same thing. This is to the first power, this is to the 1/2 power. So by cancellation, I get 16 minus x squared to the 1/2 power, or I get the square root of 16 minus x squared. Sorry, I had to check my notes to make sure that was right. And that is a lot of work there. So realistically, you probably could have stopped somewhere in here if you wanted to, but it's nice to see that if you put the work in, it actually resolves down to a nice clean expression.